Welcome, big dog. So today I'm going to show you how to connect different regions of the model. In this case, we're going to demonstrate multi-point constraints. So I went ahead and defined all the material properties in the tree. I basically just assigned them structural steel. Everything's structural steel in this model. And so let's go to connection group and let's insert a connection group. We're going to call it weldment underscore group. Once we've defined that group, we'll go ahead and insert a manual connection. So right click, insert manual connection region. And so we're going to define a connection between these two solids so that we can pull out the forces and perform our weld post-processing analysis. So we have a contact region and a target region. Contact is our slave surface, target is our master surface. And so we're just going to go ahead and assign our projected region to the target surface, and then we'll hide that and select the other interface as our contact surface. So let's go ahead and select that. So we've assigned the two. Now we can look over here in the tree and verify what we selected. So that just shows the target and the contact surfaces. Make sure you select the right thing. So that's pretty cool. And then what we want to do is we want to go down to formulation, select MPC, which is multi-point constraint, followed by we'll assign our radius of influence. So if you go down, we assign the pinball region as radius, and we're going to assign it 0.25 inches, and then we'll go down to constraint type and we'll select distributed anywhere inside the pinball. That does a really good job of capturing the nodes of interest. So let's go ahead and run it and see what it selects here. So in multi-point constraint, we can actually view what nodes are shared between the two surfaces, which is why I like to use multi-point constraints, so we can check and make sure everything's good. So if you go just hide the solution window, you'll see what nodes are connected, and that does a really good job, man, right there. It captures pretty much all the nodes between that projected region and the solid model. And so we're going to go ahead and just insert another connection group, and we're going to connect a shell to a beam. So we have this base shell and we have the series of beams. We want to assign a constraint between those two. Traditionally, I would assign a shell as the contact surface, but Ansys doesn't like that, so we're just going to go ahead and assign it the target surface. So let's just select the edges of the shell, and then we'll assign it to the target surface, and then we'll select the beam edges that we want to connect it to. And so what this will do is create contact between the two, so that when it's under loading, they displace the same amount, and they stay the same distance apart. And so we've selected all the beams. Let's apply, and then we're just going to go ahead and change the formulation to MPC, and we'll just keep the rest program controlled for now. And you can see in the window, you can verify your regions that you selected as a contact and target surface. And then we're going to create another bonded contact over here between this piping and the beam. So a solid element and a beam. So that's what makes MPC really versatile, is it can connect basically different elements with different degrees of freedom, and you can run and get a solution. So we'll go ahead and assign the target and master surfaces in this case, and we'll go ahead and change the formulation to MPC, followed by assigning a pinball region. So let's just select the radius here. Let's use 1.25, and then you can see kind of what falls within the pinball region, and we'll just go ahead and select the constraint type as distributed anywhere inside the pinball. So if you notice up here in the tree, it's got a question mark. So Ansys does not like the way we assign the contact and target surfaces. So the way to fix that is right click and select flip contact and target surface. And so that's how you do it. So I'm going to pause the video and we'll just see the end result here after I've assigned other contacts to different regions. So we've defined all our contact regions right here. In total we have 5. So I ran the solution and I'm going to hide it, and it's going to show all the connections we made. And you can see here, this shows all the contacts, what nodes are shared between each surfaces. And you can see here, that's why I like to use multi-point constraints, because I can go in here and see what nodes it grabs, because in a lot of cases you may not be able to tell with the program controlled constraints. So hope you learned something, and I'll see you next time. Adios.